This next section, we're going to expand on our rational expression operations, and we're going to talk about adding and subtracting these rational expressions. So I'm going to first go back to just dealing with fractions. If we add two fractions together, remember they have to have the same denominator. And if they do have the same denominator, we just go ahead and add the numerators. So that denominator stays completely untouched. So we can put this as a single fraction with 7 in the bottom, and we go ahead and add the numerators. That gives us 7 in the top, 7 in the bottom, which simplifies to 1. To subtract, same thing, as long as they have the same denominator, we go ahead and just subtract the numerators. And so that leaves us with 3 in the numerator and still a 7 in the denominator. If they do not have the same denominator, then we have to find that common denominator, whatever your least common denominator is. I mean, it doesn't have to be the least, it could be more than that, but least is usually good. Like if we were to change this to 5 over 7 minus 2 over 3, the least common denominator in this case would be 21, because 21 is divisible by 7 and 3. So this first piece we'd have to multiply by 3 over 3, the second piece by 7 over 7. And so the first one we can change to the fraction 15 over 21, and the second would change to 14 over 21. And now that they have the same denominator, you subtract the numerators, and it leaves you with 1 over 21. The second we now add the variable, honestly, exactly the same thing happens. So if the fractions have the same denominator, you just go ahead and perform the operations in the numerator, and you keep everything over the common. If they have different denominators, you need to figure out what is your least common denominator, write every expression so it has the same thing, and then you can go ahead and condense it to a single fraction. Once you get through all of that, then you want to go through and simplify whatever that resulting expression is. So really, we're just going to try a ton of examples. So we want to add or subtract the fractions that are given to us, and we want to write our answer in the lowest terms. So if we can simplify, we have to simplify. So these first two, we're going to start somewhat nice. The very first problem, we have 7 over x plus 2 over x. Since they do have the same denominator, we can go ahead and just add these in a single fraction. So we put them over x, we just add the two numerators together. It leaves us with 9 in the top, x in the bottom. For the second expression, same thing. We have exactly the same denominator. So we can condense this and put everything over this common denominator. So in the top, we have x squared minus 25. Now this one, though, we can simplify a bit more. So we have a polynomial up top that's a higher degree than 1. It does factor. So it factors nicely to x plus 5, x minus 5. And now the x plus 5 factors cancel each other out. So all we're left with is x minus 5 in the numerator, 1 in the bottom, which is not a problem. That's just going to cancel because x minus 5 over 1 is x minus 5. So that is our simplified expression. Now let's try some harder problems. So for this next one, we have 3 over t minus 2 plus 1 over t minus 2. So unfortunately, these are not exactly the same. So I've got to do something to make them the same denominator. And if you remember back in our other video, honestly, these are the same, but just opposite signs of each other. So I don't need to go ahead and multiply each expression by something. We can just do a little bit of manipulation. So this first one, I'm going to leave alone. And for the second one, what I'm going to do is I'm going to factor out a minus sign. because it's going to go ahead and flip those two pieces. And now I can go ahead and I have 1 divided by -1. All that really does is it changes this addition we have out front to subtraction. Okay. So we didn't need to full go through and find a common denominator because they were so similar to each other. And now we have exactly the same bottom, so we go ahead and we just subtract the numerator, and that leaves us with 3 minus 1, or 2. Okay. You could also instead take the minus sign out of here, and you'd get a slightly different looking answer. So just for completeness, let's go ahead and do it the other way. So let's make all this stuff disappear. Another way we can do this is from the first fraction. We go ahead and take out a minus sign, and that flips it to t minus 2, which is exactly what this second expression is. And then what we can do is we have 3 divided by -1, because again, this is really just -1 times that. So we can move that up into the numerator as -3 over t minus 2 plus 1 over t minus 2. And now they have exactly the same denominator, so we go ahead and just add those numerators together. And that should be t minus 2, not plus 2. So this leaves us with -2 over t minus 2. And really, that's exactly the same thing, because at this point, if I factor it out a minus sign, that would be 2 minus t in the bottom. And then the minuses would cancel and leave us with +2 over t minus 2, which is exactly what we got the first way. Now let's try something even more complicated. Now we're working with something that has completely different denominators. So just like our very first example where we went through fractions with numbers that didn't have the same denominator, we need to find what this least common denominator is so that we can make the bottoms match up. So this first fraction has an x minus 1 and this one has an x. That means our least common denominator is going to have both of those pieces in it. So what I need to do is I need to take this first expression, and the thing that's missing from it is an x. So I'm going to multiply it by x over x. And I want to subtract this second expression, and the thing that's missing from its denominator is this factor of x minus 1. So both top and bottom have to get multiplied by x minus 1 to not change anything. So this first fraction, we multiply across, we have x times 1, just x. And in the bottom, we can leave it as this factored form, x times x minus 1. Now in the top, we have 1 times x minus 1, and the x and x minus 1 in the bottom. So now we are set. They do have exactly the same denominator. So we can go ahead and condense this to a single fraction with this common denominator in the bottom. The thing you have to be careful about is this minus sign right here in the middle, because it's minus this whole expression in the numerator. So what I'd recommend doing is you take the first one and you subtract the second one. Because unfortunately, it's not like just numbers, it's the top numerator minus the second numerator. So you can make a really simple sign error here, and unfortunately, it'll be wrong. Because really what happens is that minus sign distributes, and it's x minus x plus 1 over x times x plus x minus 1. And then we can see these two x's cancel each other out, and it leaves us with +1 over x times x minus 1. So just be careful. What I've seen a lot of times is we just have x and then we forget to do that distributing. So we just say, oh, it's x minus this thing. And then that would leave us with -1 instead of +1. So we'd end up with something that isn't quite correct. So just be super, super careful. I think the easier thing to do is say, okay, now that I have the common denominator, I'm taking the first one and I'm subtracting this entire expression for the second one. Let's try one more, and now we've got 3 fractions that we are subtracting. So I still need to do the same thing of finding a common denominator, but for this third expression, it is not factored yet. So I want to go ahead and factor it as much as possible. So this way I can see what factors need to go into my common denominator. And be careful that you copy it down right and don't make tiny mistakes. So luckily x squared minus 9 does factor nicely into x minus 3, x plus 3. Okay. Now from here, I've got x minus 3 that appears, or x plus 3 that appears in 2 denominators. And we definitely need an x minus 3 in our common denominator. So for this one, the least common denominator is just those 2 factors. Those are the only things that we see appearing. Okay. So to make this first fraction have the correct common denominator, we need to multiply it by x minus 3 over x minus 3. This second one has x minus 3, so we need to multiply it by x plus 3 over x plus 3. And then the last one, thankfully, already has both of those factors, so we don't need to actually multiply it by anything to get this common denominator. And again, I'm not going to multiply anything out right away. I'm just going to write this first one as 4 times x minus 3 over this common denominator of x minus 3, x plus 3. Then we've got a minus x times x plus 3 over our common denominator. And then this last one is just minus 18 x plus 3, x minus 3. Okay. Now we have the same denominator, so we can go ahead and just make one giant fraction. Make that a nice straight line with x minus 3, x plus 3 in the denominator. And again, this is why not multiplying out will be beneficial, because I'm just going to go ahead and take the first numerator, subtract the second numerator, subtract this third one. So I do want to simplify this as much as I possibly can, at least in the numerator. So we do have to distribute that stuff out. That leaves us with 4x minus 12 minus x squared minus 3x minus 18 over this common denominator. And now we can go ahead and write things in order. I'm going to put the x squared terms first, which is negative x squared. 4x minus 3x leaves us with positive x. Minus 12 minus 18 is negative 30. If this end expression did factor, you would have to do that, but unfortunately, I'll tell you this one does not factor. Okay. So these are our main operations working with these rational expressions. Now from here, we're going to continue to build on these ideas.